When you hit the power button on a Linux machine, over 100 services spin up in seconds, not one by one, all at once. That's systemd, and it's not magic. It's a graph problem solved well. Awesome Linux TV, here's how it works. For about 2 decades, Linux used something called sysvinit. It ran a long chain of shell scripts in a fixed order. Each script had to finish before the next one even started. A slow network check or a hum service could hold up everything behind it, and every script was handwritten, so quality varied wildly. Debugging was painful. Systemd replaced all of that. It's the first process the kernel starts, PID1, and every other process on the system is its descendant. Instead of shell scripts, it uses plain text unit files that describe what to run and what it depends on. That simple declarative structure is what lets systemd figure out what can run simultaneously. The fundamental building block in systemd is the unit. A service unit describes a long-running daemon. A socket unit listens for incoming connections and starts the service only when something actually connects. Mount and timer units handle file systems and schedule tasks. And targets group sets of units under a single name. We get to those. Here's the key. Systemd reads every unit file's dependency declarations and builds a graph. Journal has no dependencies, so it starts immediately. udevd has no dependencies either. They launch at the same time. Networking needs device info from udevd, so it waits. CHD needs the network. Meanwhile, Journal was already running the whole time. Scale this across 100 units and you get massive parallelism, pure dependency resolution, no threading tricks. Targets are how systemd decides which state to boot into. Graphical.target pulls in the display manager, audio, networking, everything a desktop needs. Multi-user.target is the server equivalent, just terminals and daemons. When systemd reaches a target, it recursively resolves every dependency and starts them all in parallel. It replaced the old numbered run levels, which nobody could ever keep straight. You can actually watch systemd's decisions after the fact. Systemd analyze blame ranks every service by startup time, great for spotting bottlenecks. Critical change shows the single longest dependency path, the one that determined your actual boot time. And systemctl status gives you the state, PID, and recent log lines for any individual service. No guesswork. Systemd made boot fast by doing one thing right, modeling every dependency as a graph and starting whatever it can at the same time. That's the entire trick. Thanks for watching. More from Awesome Linux TV next time.